Hey, welcome to this lesson on lines and angles. What you're going to want to do to start off with this flipped class idea is grab a piece of paper and something to write with and take down a few notes. Now, a couple things you can do. You could do a screen capture here. So for example, if you're using a Mac, Command Shift 4 would allow you to capture this screen as a picture. You wouldn't necessarily have to write everything down. Um, I'm not as familiar with the method for Windows, but if you Google it, you'd be able to find out how to do that with a Windows computer. Using that might save you a little bit of time because you're going to want to take down the notes from a slide like this just to have for further reference. And what I'll typically do is say that I'll pause the slide so that you can have time to, that you can pause the slide so you'll have time to take down the notes. So I would say this is slide 1. And then I would actually move on, but you could pause the show and either capture the screen or write down any notes from this slide. But I'm actually going to spend a little bit of time talking about this one first. In talking about parallel lines, you guys are familiar with that, and perpendicular lines, you're familiar with that. Skew lines, maybe not so much. So let's talk about what skew lines look like. So a skew line, as it says here, they are not coplanar, and they are not parallel. So what you have to take is, I'm going to grab like line AE here. Okay, so that line AE is parallel to BF, to WH, and to CG. So I don't want it to be parallel, but it's also in the plane with AB, BF, and FE, so I don't want it to be in that plane. So I got to pick something that's not in that plane, but it's also not parallel. So a prime example would be line FH here. So what we have here, these two lines will never intersect each other because they're in different planes, and they also are not parallel. So they're not in the same plane because they'd have to be parallel, and they don't intersect. So we would call those skew lines. There's plenty of examples here. Another set that I could take is like CG down here and BW over here. Just going down that line. So CG and BW would be skew lines. Again, two lines that are not coplanar and will never intersect. Of course, parallel planes, remember your planes have to have 3-letter names, 3 non-collinear points as the name. So if I take plane ABE, that's the top plane here, the 3 letters that I've chosen, A, B, and E, that are not collinear. So I've got those 3 points that make up this top plane. Then the plane that's going to be parallel to that is going to be the bottom plane. So I'd pick any 3 points from that. It doesn't have to be CDG as it's listed here. Any 3 points. So I could say CWH. Plane CWH would be a fine name for it. Say plane CGH is fine. So in fact, they've said CDG, but actually this should have been something like a W. So there's a little correction that we need to make. Okay, so CDW would be a good plane to be parallel to ABE. Okay. All right, moving on. If you need to continue with this slide, you can pause it, and I'm going to move on to the next slide. Okay, again, I would have normally said slide 2 and just moved on, but this is one that I want to talk about a little bit. This idea of the transversal. So when you have 2 lines like we have here, R and S, and they are cut by a single line, both of them have been intersected by this line T. That line T is called the transversal. And so we have 8 different angles that have been created here. And as you can see here, this brown area, these are the angles that are between the 2 lines, and they're known as the interior. Should make sense. And the angles that are outside of those 2 lines, 1 and 2 and 7 and 8, are known as the exterior. Now what you're going to need to focus on is this particular area right here, these terms. This stuff right here, besides being important, is all over the ACT and the SAT exams. Pretty much any test you ever take, standardized test that you ever take in geometry, you're going to see this stuff. So this is very standardized test laden stuff. So you're going to want to know this for helping you to get into college. But it's also pretty important in terms of the relationship with parallel lines that we'll discuss a little bit later. Right now we're just going to identify these different terms: corresponding angles, alternate interior angles, alternate exterior, and same side. Here's how it works. Corresponding angles, it's just angles that are in the same corresponding location on two different lines. Here's an example. If I choose angle 1 here, angle 1 is, when I look at my transversal T, it is to the left of T. So I want to pick another angle to the left of T. Well, there's three options. There's 3, 5, and 7 that are all to the left of T. Here's the key. It also has to be another angle that is on top of its line. So angle 1 is on top of line R, angle 5 is on top of line S and left of the transversal. So angle 1 and angle 5 are corresponding angles, but they're not the only pair. You could pick a completely different pair, like angle 2 is corresponding with angle 6. Both of them are right of the transversal and both above. Angle 3 and angle 7. They're both left of the transversal and below the two lines, and angle 4 and angle 8 are both right of the transversal and below their two lines. So those are all corresponding angles. Now, when I go to alternate interior angles, you notice this part we've shaded here, this interior. Your only options for alternate interior angles are going to be these 4 angles in between the two lines. So 3, 4, 5, and 6 are our options. Now, alternate means opposite. So what we're talking about here is these are going to be angles that are on opposite sides of the transversal. So if I take angle 4, then it only two options I have that are opposite the transversal from angle 4 are 3 and 5. Now the way you do this is for alternate interior angles, one of the angles has to be connected to one of your lines that's not the transversal, and the other angle has to be connected to the other line. Well, 3 is connected to the same line as 4, so it's not the alternate interior with 4. 5 is the alternate interior. So I would choose 5 and 4 as a pair of alternate interior angles. These are two angles that are opposite the transversal and they are connected to two separate lines. Now another pair, 3 and 6. Opposite, each are on opposite sides of the transversal and connected to the two separate lines, 3 and 6. Alternate exterior angles. Just like alternate interior angles, they have to be on opposite sides of the transversal, but they have to be exterior angles outside the two lines. So we're talking about 1 and 2 and 7 and 8 as your options. Well, if I choose 2, then what I'm going to have to do is take angle 2 and I want it to be opposite side of the transversal, which leaves me either 1 or 7 as my other exterior angles, and it has to be connected to the other line. Well, 1 is connected to the same line as 2. They're both connected to R, so I have to choose 7. So 2 and 7 would be a set of alternate exterior angles, and the other set would be 1 and 8. 1 and 8 would be alternate exterior. Last but not least, same side interior. This is the most common name for this, but your book uses this term as well, and you'll see this in other textbooks as well, consecutive interior. You need to be familiar with both. So if you hear same side interior or you hear consecutive interior, it means the same thing. And what it means is you are, again, one of these 4 angles on the interior, and it's the 2 angles that are on the same side of the transversal. Well, if this is my transversal T, then angles 3 and 5 are same side interior angles. So are angles 4 and 6. Those angles are on the same side of the transversal and are both in the interior. All right, moving on. This theorem 3.1 here, again, we're just getting basic information in this video here. So 3.1 says that if two lines intersect to form a linear pair of congruent angles, then the lines are perpendicular. So what we have here, we've formed a line. We have a linear pair. We know these two angles form a linear pair, and we see that these two angles each have a single arc mark, so they're congruent. Well, if you have a linear pair, you know the two angles add up to 180, and if they're equal, the only two equal angles that add up to 180 are 90 and 90. So that tells me that these angles have to be 90. Therefore, these these lines, G and H, have to be perpendicular. So we use our perpendicular symbol here to represent that if these are a linear pair of congruent angles, then these lines are perpendicular because those angles are right angles. This theorem 3.2, it's kind of a duh theorem when you sit back and think about it. It says if two sides of two adjacent acute angles are perpendicular, then the angles are complementary. Well, basically what you have here is your segment addition postulate. We know that this angle plus this angle right here has to equal the measure of the whole angle. That's the angle addition postulate. Well, if the whole angle measures 90, then the two angles that add up to the whole angle are adding up to 90. And when two angles add up to 90, they're complementary. That's the definition of complementary angles. So this theorem, while important, it's pretty common sense. So two angles add up to 90 degrees, they have to be complementary. And then last but not least, this one may be a little tougher to look at because of all the boxes that are on it, but here's what I need you to see. The original intent of this is you got the two lines intersecting, and here's what I know. Just that box, saying that that is a right angle. So that tells me that the two lines that intersected are perpendicular. Well, basically, this would be one of the easiest proofs to do, to show theorem 3.3 is true, that all these other angles have to be right angles, because start this way. Create your line here. Well, we have a linear pair. If this is 90 and this is some other angle and they form a linear pair, they have to add up to 180. If this is 90, well then this is 90. Now look here. Vertical angles. This angle and this angle are vertical angles, therefore this is congruent to this, so this is also 90. And then I have another linear pair, so these are also 90 degree. This is also a 90-degree angle. So pretty easy to prove. You can use either three sets of linear pairs or two sets of linear pairs on a set of vertical angles to show that all four angles have to be right angles. All right, moving on. Now, this is not your eyesight. This really is that fuzzy, so I apologize, but should be able to get the general idea from this. We're supposed to identify a pair of parallel segments. Well, there's a ton, so it's not like there's a single right answer. You could pick several here and be correct. So what I'm going to choose is segment BF here, and I could choose any other segment with it that's parallel as long as it's going up and has this little single arrow on it. So that's CG, DH, or EJ. So any of those three. So the slide here has us choosing BF and EJ, but it would have been perfectly fine to choose BF and CG, BF and DH. You could have not even chosen BF at all, CG and DH, but you could have gone a completely different route as well. We could have chosen these double arrows. BE and CD are parallel segments, or BE and FJ, CD and FJ, and then GH as well. So those are all parallel segments. In picking a pair of skew segments, I'm just going to stick with this BF choice here, and I just want to pick one that's skew to it. This one would work just fine. ED. That one is not coplanar with it and will never intersect with it. JH would work just fine. GH would work fine. CD would work fine. Any of those with BF would be just fine. So DE, or I called it ED, it doesn't matter. It doesn't matter what order you put those two letters in. So BF and ED are skew segments. A pair of perpendicular segments, well, I only have one pair that I can choose from, because the one thing you have to remember in geometry, we can't assume anything from a picture. We have to go by what's marked. And the only thing we have marked here as a right angle is this one right here, which is connecting segment BF and segment FJ. So those are the perpendicular segments. And then finally, a pair of parallel planes. There's a lot of choices, but the easiest one to choose from is to just look at the top plane. Any three letters from the top plane, CBE would be fine, CBE. And any three letters from the bottom plane, so GFJ. So the screen here, we have FJH, so they went for these three letters, FJH, and plane BCD, they went for those letters there. Any three letters from the bottom connected with any three letters from the top, and that those planes are parallel. Okay. Again, if you need to pause and write some of this down, feel free to pause the video. I'm going to move on. Here we're supposed to give an example of each type of angle, so corresponding angles we talked about before. They need to be on the same side of the transversal and in the same position. Well, I'm going to say 1 and 5. They're both left of the transversal and they're both above their respective lines. Now the transversal, the way I know the transversal is this vertical line here, is because I have two lines and those two lines are intersected by a single line. This single line, this vertical line, intersects my top line running left to right, and it intersects my bottom line running left to right. The line that intersects both is the transversal. So 1 and 5 are left of the transversal, and they're both above their respective lines. 4 and 8 are corresponding angles. 2 and 6 are corresponding angles. They're right of the transversal and above. 3 and 7, right of the transversal and below their lines. So any one of those pairs. We have 1 and 5, the first one that I picked. Alternate interior has to be interior angles. That's going to be 3, 4, 5, and 6. Has to be opposite sides of the transversal. So if I pick 4, I'm left of the transversal. I got to pick one to the right, but it has to be attached to the other line, which means it's got to be 6. 4 and 6 is a pair, which means the other pair is 3 and 5. Alternate exteriors, same idea, except I'm stuck with exterior angles, so 1 and 2 and 7 and 8. If I pick one, I only have one choice. Opposite side of the transversal and connected to the other line. 1 is on the left, 7 is on the right. So 1 and 7 would be alternate exteriors, which means the other pair of alternate exteriors, 2 and 8. And then same side interior, remember those are also called consecutive interior angles. Again, it's all interior, so 3, 4, 5, and 6, but they have to be on the same side of the transversal. So 4 and 5 are on the same side. They would be same side or consecutive interior angles, and 3 and 6 are on the same side. Okay, now we want to identify the transversal. And what we've done here is by having 3 lines intersect, it just makes it a little bit tougher to look at and decide which is the transversal. So I'm going to give you a little tip here. Look at the angles and see what 2 lines make up the angles. So what I've got here is for angle 1 and angle 3. So angle 1 is made up by line L and line N. See, if I follow line N up here, it hits at angle 1, and if I follow line L here, it hits at angle 1. So angle 1 is created by those 2 lines. Now I'm going to use a different color here. So angle 3. This angle right here is created by, once again, line L, and follow it down, line N. Now here's your question. Which line was used both times? So in other words, when I was looking at the lines that made up my 2 angles, which was the line in common? It was line L. Line L is my transversal. Okay. Now, these would be corresponding angles if line L is the transversal, because they are both below the transversal, 1 and 3, and they are both left of the other lines M and N. So that makes them corresponding angles. All right, 2 and 6. The 2 lines that create angle 2 are line L and line N. So L and N make 2. And then angle 6 is made up by M and N. Well, L and N, M and N. N was the common factor, so N is the transversal. Now, if you look carefully, as N being the transversal, then the other 2 lines, first of all, 1 and 6 are both it's kind of left and down, but left of the transversal. They're both on the same side of the transversal, and look, they're both between the other 2 lines, L and M. So that means they're on the interior and on the same side. They're same side interior angles. So 1 and 6 are same side interior angles, and N, as in Nancy, is our transversal. I'm sorry, I was looking at I apologize, I kept saying 1 and it was angle 2. My fault on that. So angle 2 and angle 6, Apologize for making that mistake. But angle 2 and angle 6 are opposite sides of transversal n, and that's why it's alternate interior angles, not same side interior angles. So even the teacher makes mistakes from time to time. All right, 4 and 6. So looking at angle 4, if I follow a line, I've got line M. And if I follow the other line, I've got line L. So M is in Mary, L is in Larry. And then 6 is made up of M and N. So I had Larry and Mary for line 4, Nancy and Mary for line 6. Mary is the common, so M is my transversal. Now as I follow M as my transversal, I notice that 4 is to the right of the transversal and 6 is to the left. So these are going to be alternates. I also notice that they are both outside lines N and L. This one is above L for 4 and 6 is below N. So they're on the exterior and on opposite sides of the transversal. That makes them alternate exterior angles with transversal M. Okay, now your part, what you need to bring to class, is this quiz. And there's 2 slides for this, so I'm going to have you answer the 4 questions on this slide. You're going to need to pause it because I'm going to move on. And so this is slide 1 for the quiz that you need to bring to me. Here's slide 2. Answer all 8 questions, bring them with you tomorrow to class. We'll do a couple formative assessments in class and then get on to the assignment. Have a great day.